Hi guys, welcome back to my channel. If you are new, my name is Erica and I am going to be entering nursing school in a few weeks, and in order to get a head start, I've gone ahead and started learning dosage calculations using dimensional analysis. I found that dimensional analysis is a foolproof way to get to the end result of whatever dosage calculations questions are being asked, and it just keeps everything nice and tidy and organized. And I'm going to go ahead and show you a few questions on how I use dimensional analysis to get my answers for any basic dosage calculations question. I have done some advanced dosage calculations questions and it does still work, so that is great to know. I find that this is something that we should probably have been taught years and years ago, especially in algebra. It would have really been useful because it's just a foolproof way to getting the correct answer. So I'm going to go ahead and start with some basic questions first. If you haven't watched my first video on just basic conversions, go ahead and head over to that video. I'll link it down below. But if you are ready, grab a pen and paper and let's get started. Okay, so our first question is fairly simple. The doctor orders 55 milligrams of drug A. So the drug name or type doesn't really matter. It's what the order is. So it's 55 milligrams. So what I like to do is I like to write out the important information first. So I'll always start out with doctor's orders. And it is 55 milligrams of whatever drug it is. So drug A. And the stock available is 20 milligrams per milliliter. So go ahead and put stock, and that's 20 milligrams per milliliter. Okay, so what is it asking us? It's asking us to give a patient 55 milligrams of drug A, but our stock is in milliliters. So what we're going to do is we need to find how many milliliters to administer the drug to the patient. So that is our question. So what we need to do is find milliliters. So we're going to go ahead and put milliliters here. This is going to help us in the dimensional analysis portion. And what I like to do is start off with the information that I have in milliliters. So we have milliliters here, and this is per milliliter. So there is technically a 1 in front of this. So keep that in mind. If there is just a unit, there's always going to be a 1 in front of it. So I just put 1 milliliter, and then this information goes in conjunction, so we have to include it. So we're going to go ahead and include it down below. And in dimensional analysis, we have to carry our units diagonally from each other. So if I have micrograms here, micrograms must go here. So I look into my information given and I see what do I have in micrograms, or excuse me, milligrams. I'm sorry, I mean milligrams. I have 55 milligrams, so we're going to go ahead and use that. And it's 1 dose. Okay, so we're going to go ahead and put 1 down below. And we can go ahead and cancel out any units that we have. So we have milligrams here and milligrams here, and what we are looking for is for milliliters, and we have milliliters here. So all we need to do really is just multiply straight across. So we have 1 times 55, it's 55 milliliters, and then 20 times 1 is 20, and then we divide 55 by 20 and we get 2.75, and most often or not they will ask us to round, so we are going to round this up to 2.8 milliliters. That is our answer. Okay, so we're going to go ahead and go to question number 2. This one's a little more complex. It has a bit more information, but remember that they will probably give us more information than we need, and we just need to figure out what the question is asking and omit the extra stuff. The extra stuff is there to confuse us. We don't want to be confused. We want to make sure that we are administering however much the order is based on the stock available. So this doctor orders 300 milligrams of drug B. The stock is a vial of 25 grams in 50 milliliter solution. Okay, so the order is 300 milligrams, but we need to find out how much to give in milliliters. That is the question, since it will be coming from a vial solution. So we need to make sure that we are looking for the correct unit. So make sure you think, okay, what is it asking? It's asking me to give 300 milligrams of a drug that is in a vial of a solution in milliliters. So we're going to go ahead and start with our milliliters. What in our information has milliliters? Well, 50 does. So 50 milliliters. Remember, if there's information attached, we have to bring that with it. So we're going to put it down below. 25 grams. And this is a conversion. We need to convert grams to milligrams. So if we have grams here, grams must go here. Well, I know if you have memorized the conversion units for grams to milligrams, you know that for every 1 gram, there is 1,000 milligrams. Okay, so we're gonna go ahead and start canceling out our units that we don't need. We do need milliliters. We already have milliliters here, but we need to go a step further to be able to cancel this milligrams out for us. And we still have information to plug into the equation. So we're going to go further. We have to carry our milligrams up to be able to cancel. Well, what in the information has milligrams that we haven't put into our equation yet? That would be 300. So we're going to go ahead and put 300, and this is for 1 dose. So 1 goes down below. So now we've gone ahead and canceled out the remaining units that are not needed, and we are just left with milliliters. That's perfect. Now we can go ahead and multiply straight across. So 50 times 1 times 300 is 15,000 milliliters. 25 times 1,000 times 1 is 25,000. And now we just go ahead and divide 15,000 milliliters divided by 25,000, and we end up with 0.6 milliliters. That is our answer. So that concludes our second dosage calculations video. If you want more videos like this, please give this video a thumbs up. Let me know if you have specific questions for questions you may be studying. I'd be more than happy to help. Don't forget to subscribe, and I will see you in my next video. Bye!